When a developer relies on a single premium API for every interaction, their monthly token allocation is often depleted in days. This happens because standard AI editors route every task, from massive system refactors to simple typo checks, through the same expensive cloud endpoint. It is the digital equivalent of hiring a structural engineer to spend 8 hours a day double-checking the placement of individual bricks. Moving from a builder who simply accepts these costs to an architect requires a shift toward resource management. You have to treat model intelligence as a finite utility that must be allocated based on the complexity of the task. To maintain a high shipping velocity without hit-and-run operational costs, you must find a way to break this monolithic API dependency. Google Antigravity is a VS Code fork built to solve this. It is designed for multi-agent orchestration, allowing the developer to run different models for different purposes in the same workspace. This setup enables subscription arbitrage. By routing command line tools through your existing web subscriptions via OAuth, you can bypass per-token API billing entirely. We achieve this through a 4-lane workflow, a systematic routing of tasks across Claude, Gemini, Codex, and local Ollama models. When you draw exclusively from subscriptions you already pay for, your net API cost for these frontier models effectively drops to zero. Instead of a single model bottleneck, we distribute the workload across 4 specialized lanes that operate in parallel. This architecture fixes your engineering overhead. Your costs stay the same whether you ship 10 lines of code or 10,000. The first lane handles high-level architectural planning, directory structuring, and project outlines. For these tasks, we use Antigravity's native model picker to select Gemini 3.1 Pro. Gemini's 1 million token context window is specifically suited for ingestion of massive documentation sets and high-level mapping. During the Antigravity preview, this native model access is free, meaning your architectural mapping phase costs nothing. This creates a very strict operational boundary. You use these free tier models to finalize the plan, but you do not use them for the actual implementation. By offloading heavy planning to the free tier, you save your premium subscription tokens for the actual generation of logic. When it is time for dense implementation, tasks like deep logic handling and full repo refactors, you move to lane 2. This lane belongs exclusively to Claude Opus 4.7, running through the integrated terminal. To use Opus without API charges, you must implement profile isolation. A launcher script nullifies global Anthropic API keys, preventing the tool from charging you at pay-as-you-go rates. Hiding the API key forces the session to authenticate against your prepaid Max subscription via OAuth. Before starting a sprint, run the status command. If it shows Max plan, your traffic is being covered by your subscription. Scoping your environment variables this way acts as a financial safeguard for your development environment. This isolation is the only way to utilize the industry's strongest models for heavy coding while maintaining a fixed budget. After Opus generates a code diff, you need to validate it before committing it to your branch. Rather than wasting more cloud tokens on a review, you should offload this validation to your own hardware. A 14 billion parameter model running locally via Ollama is more than capable of identifying syntax errors and structural flaws. When your local hardware successfully catches a bug right on your machine, you have completely prevented an unnecessary and expensive round trip to the cloud. Intercepting errors locally is free. It ensures that every cloud token you eventually spend is being used on a clean, validated implementation. This sovereign agent acts as your final budget gatekeeper, ensuring cloud models only see the code once it's ready for a final pass. Lane 4 is for specialized engineering that sits outside of general logic, like CI/CD pipelines or OpenAI-specific integrations. These tasks, along with automated GitHub pull request reviews, are assigned to the Codex CLI. Like Claude Code, Codex authenticates directly through your existing ChatGPT Plus or Pro plan, keeping the cost fixed. To unify these 4 lanes, we use the Model Context Protocol, or MCP. MCP connects external tools, like the Shopify Dev Connector or the GitHub integration, doing it only once. Once registered, those tools are immediately available to every agent in your swarm, whether running in the editor or the terminal. This eliminates the need to configure tools for each individual model, creating a single, highly interconnected engineering ecosystem. This chart compares token distribution, traditional workflows versus our 4-lane model. Single-lane setups consume premium allocations on high-volume tasks, causing lockouts within days. The 4-lane workflow diverts these to free tiers, removing the bulk of the context load from the premium model. This diversion reserves your premium Claude Opus allocation for the dense logic sprints that actually require its reasoning, significantly extending the lifespan of your monthly subscription. Architectural discipline allows you to ship more code on the same budget by treating token management as a strategic advantage. This is the operational standard for high-output engineering in the age of generative models. The time spent on the manual effort of writing syntax is being replaced by the strategic orchestration of model outputs. Success now depends on your ability to manage a sovereign fleet of agents, optimizing their use against both hardware latency and subscription limits. Audit your environment variables today and initialize your CLI authentications. Eliminating redundant API payments is the first requirement for any developer operating as a system architect.